Hi everybody and welcome on my YouTube channel. So today, this is the first video. I'm going to introduce myself. I'm going to introduce this YouTube channel and why MakeIT, why the name, what is the main purpose. And after that, I will talk about how to deploy a linear regression on this tiny board, which is nano 33 BLE cents. Okay, so to introduce myself, I'm Baptiste Locke, I'm French, and I'm currently studying data science at the EPF, Graduate School of Engineering. So I'm also fascinated with astronomy, as you can see behind me. You can see my YouTube channel about astronomy right here, so don't hesitate to click. Then why MakeIT? So make for maker, because I consider myself as a maker, and IT stands for IT because many of your tutorials you will see on this channel will be related to IT, but not at all, because there is some 3D printing tutorial I'm going to do, but mostly in IT. The aim is to do tutorial that I've never found on the web, so I think and I hope this YouTube channel is unique, so don't hesitate to subscribe. Okay, so now to get started, let me show you the pipeline. First thing you need to do is to identify your need. Today we want to do a linear regression. Linear regression, you have X and you want Y. This is my need and your need for this tutorial. To do this, I need to find a data set. This is simple linear regression, so we'll create our data sets ourselves on Google Collaboratory. But if you don't have any data, you have to find it on Kaggle or Google Dataset Search, which are great tools. After that, build your model using Tensorflow. Here in TinyML, use Tensorflow. It's amazing. To do this, use Google Collaboratory or Jupyter as IDE. I will show you how to use Google Collaboratory because it's my favorite one. And after that, convert your model into TFLite and then to TFLite Micro. So TFLite Micro is for microcontroller. This is a microcontroller. Okay, after that, we are in a C++ part. We'll use Arduino or VS Code plus PlatformIO to deploy our model on board and to make inference with it. The first thing you have to do is to subscribe or register on Google Collaboratory. You should probably have a Google account, it's better. So once it's done, let's encounter here. It's in my collab notebook folder. Then I've created a folder called MakeIT for all of my tutorials. So I will create the first Google Collaboratory notebook, which is the same as Jupyter notebook. Here is the blank page. The thing we have to do is to give a name, linear regression, simple name. I will not now present you Google Collaboratory. If you want me to do another tutorial for how to use Google Collaboratory, feel free to ask in comments, okay? We will create a big section called First MakeIT Tutorial, First MakeIT Tutorial, then another section, a smaller one, called Installing Tools, because we need to install Tensorflow, which is our library to design our model, and we also have to install NumPy because it's another library that uses arithmetic. We need to run shell command, exclamation mark allow you to run shell command, so pip install TensorFlow. You can specify any version you want. Pip install NumPy, run cell, done. As you can see, it's already satisfied because I already installed all this library, but for you it's not the same. Then we will test if it's okay, so import make code. So we'll import TensorFlow as TF, short for TensorFlow, it's easier to call, and import NumPy as NP, also easier to call. To verify it fits good, we can print the version, tf version, comma, tf dot version, same for NumPy, version, okay, comma, np, okay, that's okay. So now, as I said on the pipeline, you have to find dataset or create it. So now we'll create the dataset. So we want to do linear regression. So we need two arrays or two vectors, one for X, another for Y. We create the same, we create together np.array parentheses, np.array parentheses. We'll define an equation, 2 times X plus 1, this is equal to Y. On the X vector, we have to fill it with, for instance, 0, 1, 2, 3, okay? And on the Y vector, we have to calculate the y values. 2 times 0 plus 1 equals to 1 equals to 3, 5, 7. So that's it. And we have to specify the d type, data float, easier to compute for TensorFlow, type float, and we can print it out. So x, y, y. That's it. We have our two vectors ready to design our model. As I said, we have to create our model. This will be probably the simplest model you've ever seen. It has only one neuron on it. We'll create a little section more building model. It's okay. Code. We'll call it our model simply equals to tf.keras.model.sequential, because we have a sequence of layer of neuron, open brackets, and on it you have to specify all the layer you want to do, and on each layer specify the number of units you want. Units are neurons, and the input shape or activation functions, or many things. This model has only one layer, so we'll create a layer, so tf.keras.layer dense, because neurons are densely connected. Only one unit, so because we enter x and we output y, so that's it. Comma the input shape, so no activation, only specify input shape equals, and because x is only one number, so one element of this vector, only an array of one element, our model is created. So we have to compile it to specify other parameters. The optimizer, we have many optimizers, so you can specify it as like it, SGD, so stochastic gradient descent, or Adam, or many others. So we'll take SGD. We have to specify loss function. Here it's a linear regression problem. The most easiest way to measure loss is mean squared error, but you have many other loss functions, such as binary cross entropy, categorical cross entropy, and then we define a matrix. We'll select accuracy. Oh, so that's it. Run this cell. That's it. You can run the command model.summary to see your model look like. We have only one neuron and one dense layer. Now our model is designed. We have our data sets, so we have to combine both together and train our models. We have to fit our model using all the parameters. So x stands for x, y stands for y, and we have to specify the most important thing is epoch. So epoch is the number of time you will iterate on. Here we will take 500, but here it's a simple model, so if you got a bigger model, don't take too higher epoch because it may take a long time. That's it. You can also specify validation split, validation data, shuffle, any other parameters, so all are here. I'll let you explore it. So we only have to run this. Our model is computing, so you can see that the loss is decreasing a lot. That's a good point for us. You can see that by testing our code. So we can print model.predict to predict a value, open parentheses. We have to make 1x, we'll take 9 and simply run it. As you can see, we have 19, so that's good. Model was right. You can verify by computing yourself. Print 2 times 9 plus 1, and it's 19, so our model is right. We have to convert our model into TFLite. First thing we need to do, you have to create a converter called tf.lite.tfLiteConverter.from. So you can use Keras model or from save model if you save your model already here. Keras model, and then our model. After that, convert it. .convert. This thing equals to our model converted. Okay, and after that we have to write our converted model on the directory here. So we have to open the file model converted.tflite in the mode wb to write, and we will write model underscore converted. That's okay. Simply run it. If you refresh Here it is. So now we have to convert it into TensorFlow-like micro. You have to install with shell command apt get -qq install xxd. So xxd is our tool to convert model. This is a Linux or Unix command, shell command. So simply run it, and then we have to convert our model and write it into a header file. So first thing we need to do is to fill our file with const and sign char model bracket open curly brace, write it on content, which is this folder model.header. This is our C++ file. Then cat model underscore converted .TFLite. Sorry, mistake. And pipe xxt -a and write it in the same path. So .h, and then finish the file with echo and close the curly brace and semicolon. Write it on content model.header. Run it. Now that's good. Here is the file. It's such a big array. This is our parameter, and this is a C++ file. Download it. Here, download. And now we have to use it onto an Arduino C++ file. Can run it on our board. So we have to create an Arduino project. To do this, I prefer using Visual Studio Code and PlatformIO. Don't worry if you have never used it. I will make another tutorial how to get started with PlatformIO. Just follow the instruction. Open Visual Studio Code. You have to install PlatformIO from extension here. It's already done for me. Just click on it, open PlatformIO, create a new project here. Project name will make it underscore linear regression. So then here select your board. My board is Arduino Nano 33 BLE sense, so I will put Nano 33 and select the Nordic, and I will select my own location. So browse to your computer, project, finish. Then now your project will be created and all the directory will be organized, and I will explain you a little bit. The main explanation of this will be in another tutorial called Getting Started with PlatformIO and VS Code. I really love Visual Studio Code because you can compile any language, and you can run, for instance, TinyGo, MicroPython, designed for microcontroller. So for me, Visual Studio Code is the best way to code. Our project is here, so we can close it. First thing you have to see is in src, the main.c++ file. This is where we code all the Arduino code, so we already have includes arduino.h. So we'll put all the stuff here. Then in lib, if you have external library in a folder, you can put it here. In include, you have only .h file, so here we will put our model.h. Don't have to touch. And in test, I never use. Here you have to specify the monitor speed. With this board, I prefer 9600. So that's it. You can specify many other things. So platformio.ini. Okay, first put your model.h into includes like this. Paste it here. Here it is. If you go to your studio, here in include you have your h file. Here it is, the same as in Google Laboratory. So we can close it. Next thing you need to do is to import Eloquent TinyML library. Go to library. If you don't have PlatformIO, go here and click on open. Here we use Eloquent TinyML. That's it. Click on it and then add to project. So here's our project. That's it. Go here and you can see in PIO libdepth, and here is our eloquent tinyml library added here. So if you have another library added here, but most of the library are already in PlatformIO. Okay, so next part, add include eloquent tinyml.h and include our model, so model.h. So that's it, our model is here. Now we have to specify, so define number of input, number of output, and the size. nb underscore input, you have only one input. Define nb output, only one, and we will make tensor area. Okay, so that's it. This is the size our model will take. So I don't know yet how to really define it precisely, but I think you can multiply this value by number of input times number of output. So for me, this is the rule. Then we have to create our object model. So this is a namespace, tinyml TFLite, sorry, lowercase t, open it, number of inputs, number of outputs, and tensor arena, sorry, like this. Okay, I will call it my model. Okay, we have created our model here. As every Arduino project begin the serial in 9600. Okay, and also you have to make my model.begin with our model. So here model is the object into our header file here, so I can show you. Here it is, the name. And now we have to make inferences. First thing we need to do, we'll create an x, float x equal random to 20 plus random 10 divided by 10 to have decimal part. So we have a float here. We have to create input called calibrate x, so like this. Okay, sorry, I have to specify the size here, or nb input, so it's better now. Then I have to float outputs equals to my underscore model dot predict input. So that's it, and it's done. I will print x serial dot print x dot print y. We'll make a space here, y print 2 times x plus 1. So this is real y, and the predicted y is predicted y here. So serial reference ln output. Okay, that's it. Now we'll test it. I have my board here. I plug it into my computer. Done. Sorry, here. It's okay, no problem. And I will do build and upload, so like this, and it will auto detect the COM port. Let's PlatformIO upload. Currently uploading the code here, so it's compiling everything. Don't worry if you see yellow lines, it's only warning. Don't worry. Worry only if you got red line. Okay, that's it. It took almost 10 seconds, so it was way too long. And just click here to start serial, so you can monitor and you will see this. Okay, that's it. Here we are. You have x, which is equal to 1, the true y, and the predicted y. You can see such great accuracy. I'm really happy. You can run and make inference with this little bar. Impressive for me. And this library uses Tensorflow Lite Micro. It's only available on ESP32 and Nano 33. Cannot run and make inference on ESP, for instance, 8266. So there is another way to do it by using scikit-learn model, and I will explain it in another video. So stay tuned and if it was good for you, feel free to let me know in comments, and don't hesitate to like it and to subscribe to my channel. Stay tuned.